Okay, welcome to this webinar, Techniques for Rendering Realistic Models in Inventor. Okay, my name is Aldred Boyd, and I am an application engineer for micrographics. You can just see at the bottom my email address, so if there are any questions that you'd like to ask over email or via email, you can more than welcome to sort of email me for them. Okay, so just a little bit about myself. I'm an industry specialist for the manufacturing products. So that is your AutoCAD plant, AutoCAD P&ID, AutoCAD mechanical, AutoCAD electrical. My main product is, well, I'm focused on Inventor. And, with that also the data management software, the Vault as well. So I mainly focus on that over there. I've been in the industry for about 18 years now, so I think I might know what I'm talking about, or I might not know. Autodesk is always bringing out new features and new products as well, which I need to learn. So yeah, it keeps me young and healthy. I'm also both AutoCAD and Inventor certified, so I've had to write my exams, as well as I'm an Autodesk certified instructor. So if you do ever come through to any training by myself, then you do know that you're in good hands. I've also presented at both Autodesk University Extension in Joburg and Cape Town, mainly focusing on iLogic, as well as just sort of increasing productivity in the Inventor products. Okay, so the agenda for today, how do we manipulate Inventor appearances for effective visuals? One might not think it, but model geometry is also very important when it comes to rendering realistically. The way that you model it, or the way that the model is portrayed. How do those edges come together? What surface do you have? The flat surfaces, curved surfaces. It also does make a very big difference when it comes to the rendering with both lighting and shadows. And then configuring the Inventor Studio settings for high quality imagery, and how to produce an animation in Inventor as well. Okay, so one thing about rendering we need to know about. To achieve a very realistic looking 3D scene, there are 4 things we need to take a look at. The model, the textures that you apply to the model, the lighting that you have in your scene, as well as shadows as well. So how are the shadows? Are they hard shadows? Are they soft shadows? And where do you see those shadows? Do you see it on the ground? Do you see it on the model? See between different parts. Then the part of Inventor that does the rendering for you is called Inventor Studio. So you might not know about this, but it is under your Environments tab, and you'll see there's an Inventor Studio button over there. So why Inventor Studio? Inventor Studio allows you to reuse existing CAD data or CAD modifications that you've done. These are things like level of details and your constraints. So for instance, level of detail would be something like a stapler, where the stapler would maybe have a 15-degree opening between the bottom and the top jaw, and then maybe you open it up to 35 degrees before you punch the stapler down again. And you can basically reuse that level of detail when it comes to animating your CAD dot or your model in the animation. It's also got a short learning curve, and why this is so is because of the user interface. Whenever it comes to learning new sort of in CAD software or features, if the user interface is familiar, then you actually get up and running much quicker. If it's not familiar and you need to sort of start looking and clicking and trying to find what button does what, it is a much longer learning curve. There is a quickish setup and render, and for the setup, yes, it is quick because everything's still in the same environment. And I say quickish for render because it is quickish to render versus say doing a much sort of more involved render in another more complicated rendering package. It does also have improved image quality, and with this I mean versus a shaded view. So the rendered view that you do get out of ray tracing will be much better than the standard shaded view that you get in Inventor. Why not Inventor Studio? The render quality is not as good as what you would get out if you sort of went to something like 3ds Max, for instance. Limited processing capability. With this, in other rendering packages or packages or software packages that are specific to rendering, you'll find that you can maybe do something like a render farm where you take 10, 20, 30 computers and they all do, sort of work of rendering maybe an animation, and it'll you kind of chop up each segment. So for like a 10-minute animation that you have, each computer might take a minute, but it all does that minute at the same time. So it'll take much less time to be able to render that animation. Whereas if you did it in Inventor Studio, it's on one PC and it has to render everything one after the other. So it'll take much longer to process that render. Limited configurability. So just the different ways that you can portray it, where shadows are, what casts a shadow. There's a lot more sort of buttons to play around with in something like 3ds Max than there would be in Inventor Studio. And also the quality. Okay, so yes, it might look the same, but sometimes it just the quality in some rendering packages, like 3ds Max, for instance, are much better, and that's why it is one of the best rendering packages in the world. You'd get a much more photorealistic image in 3ds Max, for instance, where you'd be able to take a look and say, I actually don't know if this is real or not. Whereas in Inventor, you won't get that. Okay, so when rendering in Inventor, there's two different places that you can do it in. One is just in your normal Inventor window, and this is with your visual styles. So you've seen this under the View tab. You'll go there and you can create still images with this, and change the visual style from, say, shaded with edges, realistic, or maybe monochrome or something like that. Whereas in Inventor Studio, you've got many more options to be able to do that. So you can see in both Visual Styles and Inventor Studio, you create still images, have visual styles that you can change. You have lighting styles and ray tracing as well. Whereas Inventor Studio, additional to that, has camera animation, so you can animate how the camera moves while your objects are animating as well. You can also have model animation, you can have lighting animation, and then you can have also animation effects. So take a look at the Inventor visual styles. What do we have? So we've got realistic. So that's where you're able to do your ray tracing, and that picture in the top right-hand corner shows you exactly what it looks like. You have your shaded, and then shaded with edges. Now, these are also styles that you'd model up with as well. So I like to model with shaded with edges, just for the simple fact that if I'm taking a look at a fillet, I'd like to know where it's now going to start blending into the surfaces that it's bordering. Shaded with hidden edges, if you need to see what's hidden behind, behind a certain wall or something like that. You got your wireframe and wireframe with hidden edges, so you can see through and see exactly what's going on in the internals. You've also got wireframe with visible edges only. And then for the more visual kind of styles, so say a client comes up and says, look, I'd like to just take a look at what this is going to look like in monochrome, watercolor, sketch illustration, or maybe technical illustration as well. Now, those are just different styles that you can sort of play and tweak around with to give a client a different, or a customer a different perspective of it, as well as you can also hide some of your IP as well. So those are also nice ways to kind of convey what you actually designing, but then also hide some of the finer detail that you don't want the client to be able to see. Okay, so just with your Inventor visual styles, when it comes to any of those styles that I just mentioned now, you're able to also play around with shadows, reflections, and your ground plane. Now, with the ground plane, you can see at the bottom there, okay, there's no ground plane on that, but you can see your reflections on the ground plane. It just gives a bit more of a realistic look to it. We do see reflections in real life as well, so that's something to take out of. Your shadows, so with the shadows, you've got to take a look at how hard the shadows are, how soft they are. So are they dark, are they softer? What casts the shadow? Do you have ambient shadows? So shadows on from the component onto another component, ground shadows as well. So, that is just something that I did a quick render on a realistic mode. And you can see there, it looks quite good. It took me about sort of 4 or 5 minutes to render that. And that's just on the PC where I just said I want a realistic style and, click ray trace. Okay, so with these views as well, how do we get the lighting out? So I think in Inventor 2016, Autodesk brought out HDRI and IBL technology into Inventor. And basically what this does is you are able to, instead of having to put all your spotlights on and make sure that there's enough lighting coming from a certain source, like the sun, for instance, to light up the room sufficiently or to light up the product sufficiently, what they've got is this IBL technology where you can basically take a picture of a room or an environment, can be outside, as you can see on the right-hand side, or inside, as you can see in this warehouse over here, where it sort of casts shadows or reflections of what you've taken a picture of. So there are presets in Inventor which you can sort of bring in, or you can create your own as well. I don't think there's any official way to create these IBLs and bring it into Inventor, but there is unofficial ways where you can go into XML files and basically modify them so that you can use your own IBL. If you do have the product design collections, you can create your IBL by taking a picture of the environment where your product's going to be, take it into 3ds Max, and then create your IBL, and then take it into Inventor, and then start doing your rendering over there. Okay, for materials and appearances, so this is another thing that you kind of need to get right. More appearances than materials. So out of the box in Inventor, you'll get your Inventor material library, your Autodesk material library, and your Autodesk appearance library. Now, as you can see there, the Inventor material library is read-write, and then the Autodesk material and Autodesk appearance library is read-only. One thing to take a note is the Autodesk Material Library and the Autodesk Appearance Library, they are actually shared between all the different products that you've got which use those libraries on your PC. So for instance, if I've got AutoCAD, it uses the Autodesk Material Library, and I create something AutoCAD, I put my materials or appearances on, open up an Inventor, then those appearance, it will look the same as it would in AutoCAD as well. So yeah, just out of the box, those are something that we can now start putting onto our objects. The appearance browser and editor. Okay, so as you can see over here, right at the top over there, you've got a search bar, which is quite nice because there are quite a few materials out the box that come with your Inventor, and you can just type in what you want: aluminium, stainless steel, galvanized steel, and it will then go and find those materials or appearances for you. On the left-hand side over there, you can see it's very nicely structured, and this whole window also looks the same in each of the different Autodesk products. So, if you know how to create a material here or know how to search for material over here or appearance, it'll be the same as if you had to go into another Autodesk package like AutoCAD, for instance. You'll see there it's got sort of subfolders under your Autodesk material library: ceramic, concrete, fabric, flooring. And if you go into any of the subfolders, like metal, for instance, you'll see there on the right-hand side, I've got my different my materials, with the category. So the folder is basically your category. On the right-hand side over there, you'll see there's a little bit of a filter selection as well. And it's split into your different document materials, the view type, sorting by name, material, color, or by category, and then also a thumbnail size. So you can actually see what the material is going to look like before you apply it to any of your objects. In the material editor settings, okay, so once you create a new material, this pops up over here. And one of the nice things about creating a new material, they've got presets. So as you can see over there under your preset type, plastic, metal, wood, glass, etc., it's actually then will go on the middle dialog palette over there. It'll actually sort of take away what you don't need. So under generic material, you'll have generic reflectivity, transparency, cutouts, self-illumination, bump, and tint. But if I had to take wood, for instance, it will actually filter out what I don't need over there. So wood wouldn't have self-illumination, so you could, would take it out. Or it might have reflectivity because you want maybe a glossiness to it, but it won't have a transparency because you'll never have a see-through wood. So it actually filters out what you don't need on each of the material presets. What you'll see on the right-hand side over there, you've also got your physical settings as well. And this will be used for things like your finite element analysis. So, by using basic thermal, mechanical, and strengths, it'll be able to tell you, when it's going to break and how it's going to act under certain pressures and forces and loads. Okay, so just some appearance effects that people have asked me about over the years is like, sort of how to create a white background. Okay, so this will be under your application options. And then you just go to your colors, and in your backgrounds over there, you can put it over there. White appearances for your actual your objects. So I'll put a white appearance on. It doesn't look white, but it will look white after you've done your ray tracing. You can also self-illuminate features, and in the so you can see on the right-hand side, you've got your self-illumination. And, it's quite nice for, as you can see, there's a little pressure dial gauge, and, you've got the numbers and the indicators between the numbers, and they're actually highlighted. So you can see over there, it goes all the way from dim glow LED panel LED screen all the way up to halogen lamp lens frosted bulb. So that'll give you the color temperature. You can also go and modify those color temperatures as well by putting on custom, or if you select it, you can go and manipulate the temperature as well to see if it's a warm or a cool color. You also have see-through metal materials. So for instance, like grates or something like that, maybe you're doing a platform in a plant, you want to be able to see through it because, it's grating and it is see-through over there. So you can create that in your appearance as well. Okay, one thing about when you're applying appearances, a little bit of a tips and tricks. The changes can be seen in real time. So, once you're going through all your different materials, you're clicking on it. If you have an object selected, you'll see how it does change. So you've got a bit of a vague idea of what it's going to look like. You don't want to have to go change a material or change an appearance. And then what happens is it's, you only see it after a 2 or 3 minute render. That's a lot of time wasted. And as we know, time is money. When you are going to make any edits to an appearance, duplicate it. This is because you cannot undo any edits that you've made to your appearance. So rather duplicate it so that you've already got the original if you don't like the direction you've gone in, and you can go back to the previous appearance that you had. Also note that the Autodesk library is much larger than the Inventor library. And as I said previously, the Autodesk library is also shared with other Autodesk software. That's sitting on the same PC. Okay, coming back to realism, when you are doing renders, one thing is take a look at in the real world, when you take a look at anything that you design where two, flat surfaces come up to each other, there's never ever a sharp corner. There's always either a slight fillet or a slight round to that. So, when you can apply fillets or apply chamfers, it just breaks up those two, surfaces coming up there and gives a bit more definition and contrast. Okay. Also gives more opportunity for reflection and highlighting as surfaces flow from one to the other. What you can do is, if there are a lot of sharp corners and you aren't putting any fillets in, or you do need those straight edges, create an iLogic version for your model. So, with iLogic, you can just program in, right, I need, sort of a whole lot of stuff corners to be just a little fillet, 1 millimeter or whatever it is, just to give a bit more of a realistic look to your model. Yeah. So once again, large flat surfaces, you don't really want large flat surfaces when doing rendering. This is lack surface definition. You want lots of curved surfaces, so soft gradients and crisp gradients. So, you kind of want to get, if you do have lots of large flat surfaces, I don't know if maybe it's reflective, maybe get a bit of lighting somewhere. So maybe start bringing lighting in where you can maybe cast shadows so that it breaks up that monotonous tone of the flat surface over there. Okay, so that's just the render that I took. Okay, so the one on the left, same material, same lighting, same background. One on the left over there, you can see it's got all the sharp curves. And the one on the right, I've just put some fillets in over there, and you can actually see the contrast, the difference between the two. You can see on the one on the right, the lighting is actually starting to come out. You can see the lighting and the reflection of the lights over there. Whereas one on the left, it just kind of looks like a CAD model. you could obviously tweak the material a little bit as well, or maybe put a bump on the material to give it even more of a realistic look. Because as you know, in the real world, things are in 3D, and you take a look at maybe a nice texture of a fabric or something like that, or maybe the metal has been polished or sort of scrubbed down, and it's got a bit of a roughish look to it. Okay. Another thing that you might not know about is having surface geometry in. So a lot of the time, people think that when I create a model and do a render, it has to be a solid model. It doesn't. You can use surface geometry as well, and on that surface geometry, you can add your textures, and that will also reflect and add a bit of light to your model as well. In the studio environment, you can turn the visibility on and off, and as also, just please note that the material appearance that you put onto this surface is only visible after you ray trace. So if you're taking a look at it, without ray tracing on, or without starting your ray tracing, it's just gonna look like a surface that's see-through, sort of orange, depending on your background Inventor surface that you created. Only once you've done that. And whenever I do renderings, I know Inventor has got a built-in ground plane, but maybe want to give that ground plane a certain appearance. So like gravel or grass or whatever it is, or maybe concrete. I create a surface like just a plane. So you draw a plane that's just much bigger than the model, and then also draw a plane at the back of the model, and then sort of curve it, put a fillet between those two, so that when you have got a camera on it and you render, it just gives it a bit of a different angle and also a bit of perspective when it comes to rendering. So that is something that I like to do, just to make my renders look a bit more realistic. Okay, so once you've got the geometry out the way, you also need and the appearances or materials, you need to take a look at your environment and your lighting. So environment can equate to sort of global lighting, and that's your IBL environment that you had. And then you've also got your local lighting, which is maybe spotlights or point lights that you're going to place around the geometry or the model to give it a bit more softness or brightness where you want to see. Maybe you want to take a look inside an assembly, lots of dark nooks and crannies. Just have another extra light just pointing over there to maybe lighten up the inside over there, where the global lighting environment lighting will not get into. Okay, so with the global lighting, as I said, it's the environment lighting. So what have we got over here to be able to manipulate this? So exposure, how bright or how dim it is. So, with our IBL lighting or environment lighting, there's a certain, it looks, sort of maybe a little bit darkish. You can up that exposure as well, so just make it a little bit brighter. Just be careful with, upping it too much, then everything just looks really, really white and bright. Rotation, you have that there for maybe if your model is not in the correct orientation. Instead of turning the model, then just basically rotate the environment so that it's in the position that you want. And then also scaling. So, maybe the environment's too big for it. I think if you can remember a previous slide of mine where I showed the two IBL environments, I actually had the little the wheel in the middle. So obviously that's way too big for it. So maybe if it was a different environment, more appropriate to it, then I can actually scale it down so that it looks. You can actually also see the backing of the environment as well. Okay, shadows are also very, very important. Okay, how dense are your shadows? How dark is it? I mean, if you go into any room, if you've got a very, very bright light, shining onto an object, the shadow will be quite dark. But if you've got the light sort of further away, the shadow will be a little bit lighter. Also, the softness of it, it gives it more realism. And ambient shadows is also very, very important. Ambient shadows is what shadows is it casting onto itself. So, take a look at that. How heavy is it? How dim is it? How light is that as well? So those are things that you also have to take into consideration. And once again, you learn about that through just practicing on objects that you render. Okay, then we've got local lighting. Okay, so once you've got an IBL, that's great, but then maybe you want to accentuate a certain part of the assembly, and that's where local lighting comes into play. So with local lighting, you've got your directional lights, point lights, and your spotlights. on the right hand side, you can see there's illumination. So that's once again how bright it is. You can make it brighter or dimmer. And then also, so I've got that east light is actually a spotlight. So that the tab on the right over there will change to point light or spotlight, and that is basically sort of moving it, and maybe for spotlight, for instance, where's that fade off area? Maybe the spotlight is very, very bright in maybe a 700 mil radius, and then as it goes out to 1 millimeter, it will dim as it goes out there. So that's where you can control the lighting in that third one over there. And then as you can see there, you can have your local lighting on or off. So you can have both, your IBL lighting and then some local lighting as well. Okay, so once that's done, yes, you can render just by, sort of saying, right, move my view to here and render, but you kind of want to render with cameras as well, because cameras have got more control, as well as you can also animate cameras. So while maybe a wheel is moving or rotating, you can have the camera moving from the left-hand side to the right-hand side, so you can see more aspects of that wheel with the motion going as well. So just how to create your cameras to render with a camera. If you have nothing selected in your window, just right-click, create camera from view, and it'll create that camera over there. The other way is there's actually a create camera button. First of all, you create camera, and as of there you can see you have to select a target and a position. And then you can also afterwards manipulate zooming in and out and the roll angle. So it's kind of like turning your head left to right to see, sort of at different angles as well. And then this is probably one of the most sort of creates a lot of realism, and you'll see that a lot of sort of cell phone cameras have got this as well. And in my Huawei, it's the bokeh effect. Is your depth of field, and it really does greatly improve your realism. And also, it's got a nice visual impact because you're actually focusing on the area that you want someone to look at, because obviously your eyes will focus to what's clear and not really the background, which is blurred out. Okay. One thing that you must know, please, is that this drastically increases your rendering time. And because it's, yes, I think Inventor Studio is a multi-core processing, but I mean, if you only got 4 cores and now you've got to now really multiply the calculations and your frames per second, you're going to be sitting there forever. And remember, when you are doing this, your computer is you can't do anything else on your computer. It renders on your computer. You might as well go take the rest of the day off. So probably when you are doing renders, please go do it in the evening, so that when you come in the morning, your render might be done. Okay, so in the render settings as well, very simplified render dialog box. And in this over here, there's basically 3 ways that you can time a render. Render time, how many minutes, render by iteration, so how many passes it goes through, and then until satisfactory. So it's just render and render and render until you say, like, that is actually what I want, and that's when I need to stop it, and then I will, I'll save it out as a bitmap or a JPEG or whatever we're doing. And then just you can see that you got lighting and material accuracy, high, low, and draft, I think, and then you got your filtering or anti-aliasing. And I'll just tell you what those are. I think it's the next slide. No, I think it's yeah. So as I said, low, draft, and high. You'll never actually do low and draft. For a final render, you might just do it to see, kind of what's going on. And then you'll do your high render over there. And then just with the sample settings. So when I talk sample settings, samples is what in the rendering terminology is what they call when you do a render, and it calculates each pixel as it goes along. And there are different filtering methods you've got. So box, triangle, Gaussian, Langsos, and Mitchell. Box will be the quickest, okay, and Mitchell will be the most accurate, but it also takes the longest. So whenever you do renders, and this goes for any rendering package, be it Inventor or 3ds Max, you need to sort of make a decision on what quality do I want to get out with how much time I actually have. You can't, because at a certain point, you'll be rendering, and you actually won't see a difference in the quality. But, that might be at hour 15, 16, or 17. So you kind of want to get that time down to something that's acceptable for the client, and as for yourself, and then also, but also it mustn't be too grainy. So, by playing around with those, you'll see exactly how, how to get the best renders out. Okay, and then we've got rendering animations. Now, with rendering still images, it is sort of kind of very quick in Inventor. And then now we come to rendering animations. The nice thing about animations is that you reuse a lot of assembly features that you've done. So things like constraints, parameters, and positional representations. As I said, with constraints or parameters or positional representations, it's there. You just say, right, the constraint must now go from 0 millimeters, and you need to move that object out to 10 millimeters while rotating this constraint from 0 degrees to 180 degrees. And that's a very quick and simple way to do it. If you had to take this Inventor assembly into, say, something like 3ds Max, you can only take one animation or one constraint with it. So, be aware of that. And the rest you'd have to then go and manually sort of join together and animate with the 3ds Max animation features. Animations do take time to render. And this is where you kind of got to ask yourself if Inventor Studio really is the correct tool for the job. As you can see over there, if you run it at 20 frames per second, okay, 10-second animation would be 200 images, 5 minutes per image, 16 hours and 40 minutes. Do you really have that much time to create a 10-second animation? Really, is it worth it? Okay, just with animations, it's simple and familiar. And why so familiar? I mean, you look at those two dialog boxes, they look very much like all the other dialog boxes in Inventor. Okay, so, recently now in 2020 and 2021, they have been updating the user interface. So, we'll see, if and when they update these dialog boxes as well to be the new tool palettes that they've got going on in Inventor. Just as a side note, I haven't really seen much sort of progress in development for this Inventor Studio. I think the Autodesk guys are looking at other rendering solutions, like there's the cloud rendering and 3ds Max, which comes with the collections as well. But if you do not have the collections, this is here for you to use. So this is just to make you guys aware of it. Yeah. With animations, you can only animate components that are not constrained, either distance, so moving from 0 to 10 millimeters or whatever, or rotating around it. This doesn't mean that you cannot animate components that are constrained. All you have to do is you need to animate the constraints that are attached to the component. So it's just kind of going like a level down. One thing that needs to be done is those constraints need to be made a favorite, and all you need to do is go to the history browser while you're in your Inventor Studio environment, right-click on the constraint, make it a favorite, and then you're able to animate that. Another nice thing, you can also animate fading components. So think about, sort of engine block. There you've got all your internal components there. You got your camera moving from left to right. And as it's moving, you'd like to see maybe the casing just become invisible, so you can see the inner workings of that engine, with it running. So that is something that Inventor Studio can do. Okay, the timeline, once again, simple, familiar. If you take a look at it, if you've ever done your Inventor presentations or an IPN, that timeline looks exactly the same. You've got what's being animated. You've got on the left-hand side the components that have been animated and the constraints, as well as undo, redo, play, etc. So very much, if you've been working with your presentation files, this animations timeline will look very, very familiar to you. Positional representations. Okay, so once again, I'm just showing you, you can use those positional representations in your animations, and just say, right, where would you like to start and where would you like to end, and then animate it, and then there we go. Very quick, very simple. Cameras can also be animated. So you can, as I said, as you are running your animation, the camera can also move with the animation as well. And to do that, first of all, you have to have a camera created. If you don't, it'll say, listen, sorry, but there's no cameras that have been created. then you set your camera definition for when the end of the camera for the end of the camera animation. So you've got your initial camera, and then when you click on that definition button, you now go say where your camera has to end up. And then with that, obviously, you can roll the camera or zoom the camera in and out. And then it will create the animation of the camera. You can also have a turntable effect. So with the turntable effect, you have your product in the middle, and then you specify a point on the product where your camera is going to move around. It'll make a 360-degree animation all the way around. So it's showing or showcasing your entire model or assembly over there. And then, surprise, surprise, one thing that a lot of people might not know is that Inventor actually has a video producer in here as well. So you're able to stitch your camera animations or your clips together, and then sort of make sort of a longer video or a video of different animations. Maybe a turntable, which then turns into a camera animation moving from one position to your second position or left to right. Okay. But once again, one of the cons is very simple. It's not like a video editor that you would get something like Adobe After Effects or something like that. So just please note that there are limitations to this as well. Oops, sorry. Okay, and then just going back to render settings for your animations, you can either sort of output an animation, so like an MP4 or an AVI, or you output stills. So when you are creating the stills, say for instance there's 40 renders it has to do to that whole animation, it will pull out 40 JPEGs or 40 bitmaps of that, and then you'll have to take that into sort of video editing software and stitch them all together again. Okay. And then just one thing before rendering, render on low settings, just to see kind of what it looks like, and preview with no render. Make sure you've got that on. You don't want to go and render something for sort of an hour or two, and you find out that, oh, okay, that actually didn't look correct. So just just make sure that you've got some of those settings there, so that you don't waste a lot of time. Okay, so in conclusion, with the Inventor Studio, out of the box familiarity, you know the user interface. You don't have to go relearn something or find out where a button is or recognize what a button actually does. It's all there. Probably one of the better options for animating assemblies with constraints, because it's all there. It works like it should. You don't have to take it into another rendering package and then have to go redo all of those. Just one of the cons about that is it's just going to take quite a while to render these animations. But you've got to take a look at the time savings between redoing it versus rendering it in Inventor. Very easy to create quality rendered images. Okay, and then just limitations once again, time to render animations and your configurability. Okay, so you don't have a lot of options on when you are doing these renders to tweak it as other more advanced rendering software packages have. Okay, and basically that is it. So just a quick rundown of rendered images, what to take a look at, when you are rendering in Inventor. And, this doesn't even just apply to Inventor. Some of the things we spoke about, like your models, your model geometry, textures, lighting and shadows, it sort of applies to any rendering software that you do or any render that you would do. And with that, any questions? With Inventor, so are you saying like bring the Revit into Inventor? Yes. So in 2021 and I think 2020.4, there's something called AnyCAD. So you can actually open up your Revit model in Inventor. If the Revit model changes, it will update in Inventor as well. Yeah. Yes, it is. So the nice thing about it is that, you say for instance using a banister on the side of a wall that you imported from Revit, and you said, okay, right, from the end of this wall, it must be always a meter. And then in Revit, it gets updated. Then it's going to update your Inventor model as well. Or yeah, or if you like, make it taller, then it'll actually update. It'll make the banister of Inventor, taller, or versus the wall that you've got in Revit. Yeah, yeah. Mm. Yeah, yeah. I mean, that's why I said, with the Autodesk Material Library, it's all the same across all the Autodesk software, or most of it. So if you're going into one or the other, at least you can get started very, very much more quickly than if you're going to go into something else like 3ds Max, for instance. But I mean, if you are interested in that 3ds Max, I'm going to be doing my next webinar is going to be taking Inventor into 3ds Max. And just showing what that can be done. So there's a lot more advanced stuff you can do, but I'm going to be focused more on, sort of what do you need to look at? Because a lot of people, when they do 3ds Max, they show you everything, which I think it's good, but it's too much. Exactly. Oh yes, yes, yeah, 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 yeah. Okay, awesome, fantastic, great. Thank you very much for watching. Okay. You too. Cheers, man.